Hello, IB11s. Today our topic is laws of logarithms. This is the first part of the laws of logarithms in 4C. We have already found that logarithm is a very challenging math concept to most of the high school students. And I'm hoping that you have already developed the familiarity with logarithms through two lessons 4A and 4B. In 4A, we also have introduced that John Napier was the first mathematician to introduce the use of the logarithms due to the real needs of solving exponential equations. Of course, John Napier was also the first person to introduce the algebraic laws of logarithms. So today, we will focus on exploring some important log laws. The first law is the product law. Let's look at the first example. Log 2 brackets 8 times 4. Based on the bad math, I will find the product 8 times 4 first. 8 times 4 is 32. 32 is 2 to the power of 5. Based on the log identity, log a to the power y. And this log value is just the exponent in the argument, y. So I will know this value is y. Okay, right now, let's split the product into the addition of two logs. So the first one is log 2. Okay, the base is 2. 8 plus log 2, the base is 2 here as well, 4. And we know the first one, so log 2, 8. For 8, I change it to 2 cubed. For 4, I change to 2 squared. So based on our identity, the first log is just 3, and the second log is 2. So 3 plus 2 is 5. Okay, so right now we find that this top log is the same as the log below. So means log 2 brackets 8 times 4 is equal to log 2, 8 plus log 2, 4. Okay, so I hope that you guys can have a try for this one. So log base 3, 27 times 1/9. And you guys also know this one is 3, the product is 3. And 3 means 3 to the power 1. So the log value is 1. If I don't multiply 27 by 1/9 first, I split them into the adding. So log 327 is log 3, 3 cubed. And this one is log 3, 1/9. I change to log 3, 1/9, which is 3 to the power of negative 2. So based on the log identity, this one is 3. Then plus this second log value is negative 2. Okay, 3 plus negative 2 is 1. We find that. In this case, log 327 times 1/9. I also can split this product into the adding of two logs. So one is log 3, 27, plus the other one is log 3, 1/9. So let's generalize the product law. So log cx times y. If I have a product in the argument, I can split this log value into log cx plus log cy. So this is the first log law we need to know. And you need to know what's the meaning of familiarity with this log law. The familiarity of this log law means you need to know how to use this law from the left side to the right side, and the right side backwards to the left side as well. Quotient law. Let's look at example 2. Log 2 brackets 8 divided by 4. I have a quotient, 8 divided by 4 in the argument. So based on the bad math, I do brackets first. 8 divided by 4 is 2. So 2 with an invisible 1 in the exponent. This log value is 1. If I split the numerator and the denominator in the quotient into 2 logs and put the minus sign in the middle, I will find log 2 8. Of course, this one is the same as log 2 cubed. Minus log 2 4. This one is log 2 squared. And this one is just 3 minus 2. It's 1. So from this case, I know log 2 brackets 8 divided by 4, this quotient, is the same as the difference of 2 individual logs. So 1 is log 2 8 minus the other one is log 2 4. And then the first argument is the numerator in the quotient. And then the second argument is the denominator in the quotient. One is log 3, 27 over 1/9. I hope that you can have a try to prove the quotient law in another case yourself. So this is log base 3, 27 over 1/9. 27 over 1/9 is the same as 27 times 9. 27 times 9 is 243. 243, if I change this one to a power of 3. So this one will be log 3. 243 is 3 to the power of 5. So this log value is 5. Okay, let's look at the minus one. So log 327 minus log 3 1/9. So log 327 is log 3 cubed minus log 3 1/9 is 3 to the power of negative 2. So based on the log identity, the first log value is 3. The second log value is negative 2. So 3 take away negative 2 is 5 again. And we find that the quotient law is true for the second case. So I can change this quotient to the subtraction of 2 individual logs. So here, let's generalize the quotient law. Log C, if I have x divided by y in the argument, so this one is the same as log cx minus log cy. Of course, for this log law, you need to know how to use that one from the left side to the right side and backwards as well. When you use this log law backwards, you will see I can change the minus to the dividing of 2 arguments in one log. So right now, we can see 5 questions in the practice for the product law and the quotient law. Especially, in this part, we need to look at how we can use the product law and the quotient law from the right side to the left side. Okay, let's look at the first one. Log 363 plus log 3 1/7. And you will find that you are not able to evaluate log 363 individually because there's no connection between 63 and 3. But however, both of these 2 logs have the same base. With the adding in the middle, I can combine these 2 logs by using the product law from the right side to the left side. So I can combine these 2 logs with the same base and change these 2 arguments into the product. So it's 63 times 1/7. 63 times 1/7. This one is 9. So log 3 9. 9 is 3 squared. the final log value we found, this one is number 2 only. So we found that with the product law, we can change two individual logs which had no relevance to their basis to the product of these two arguments, and thereby the new product has the connection with the base. Okay, the same idea for the second case. Log 2, you will see no base, which suggests the base is a common base 10. And this one is the same, a common base 10. And log 10, 2 plus log 10, 5. And it's so tough for you to find this individual log value because there's no connection between 2 and the 10. But however, if we use the product law, we multiply the arguments. 2 times 5. Okay, we will find that the product is 10 and the base is 10, and this is 10 to the power 1. So I know the value is just the invisible exponent 1. We can find the log value for log 2 plus log 5. Let's look at log 5, 500 minus log 5, 4. So this one is the minus in the middle. So if it's the minus, we do log 5 and I divide it by 2 arguments. So this is the quotient law. So 500 divided by 4. You know the quotient is 125. So this quotient 125 is 5 to the power of 3. So this log value is just 3. Okay, so let's look at number 4. In number 4, we have adding first, then subtraction. And you guys know that adding and the subtraction, we just follow the order they occur. So I will add these two logs up first. So both of them have base 6. I can multiply the arguments, 72. Then minus log 62. They still have the same base. I can divide the arguments. 72 divided by 2. Okay, and now you guys know this quotient is 36. So 36 has the connection with the base 6. And this one is 6 squared. So I will know the final log value is number 2. In number 5, we see minus first, then adding. So we follow the order they occur. We do minus first. So it's log 2. I do dividing 384 divided by 36, then plus log 2, 3. And if you use the calculator, you will see 384 divided by 36. The answer is not a nice number. It's a repeating decimal. So, but anyway, division is not a kind of urgent thing for us to do. So I will use this entire division. 2 times by 3. A fraction times a fraction. And I find that this is 3 and 36. Both of them have a common factor of 3. So I can make this one 1. I can reduce 36 by 3, which is 12. So 384 divided by 12, and this value is 32. So 32 is a good number because 32 has the connection with the base 2. And this one is 2 to the power 5. So I know the final value is 5.